I haven't been able to um, utilize the negative marking so far. So I was thinking that maybe in the evening will be better. By that time, possibly I'll go do that. I will do something regarding the negative marking actually, or maybe I won't keep this time. 4 to 8 you can't give, Anjana. Okay, okay. Let me see. I'll try to make it so that. Oh, okay. I'll just try to make sure that you could take it anytime you want. Okay, I'll just set up a time limit. Okay, and just try it anywhere. I just send the link and you could try it. Okay, after that you could do that. You can do it Monday if you want. Fine. I'll just, but by Monday you should finish it up. Okay, and I won't discuss the answers before that. A Google Meet app in laptop. You don't need to install anything, Devjyoti. You have to just go to meet.google.com. The website is meet.google.com. There's no need to install anything. You just go to that website. Ahinda, what did you ask, by the way? Your question is where? Last summer dimensions, sample test paper. Last question implies that let's people are just coming. Hold a moment. 7 by oh, I mean today's maths class, isn't it? Okay, I will just put the solution. Right now it is maths class, so I will take a maths, but I'll put the solution after the class. Before your exams, you can see it. Okay. I thought it was quite easy, by the way. There was a factor of, I mean, okay, fine. I'll just solve it and put it over there. Okay, it's not much bad. That was the question you're asking, Anindu. It's 7 by 2 factor, 7 by 2 power. Okay, I'll do that. I will simply put the solution in the group after the class. Okay. Okay, there is one thing I would like to talk about before I. Okay, we'll take up the inequalities that we're talking about. There are a few more inequalities I would like to talk about. A few people send me questions regarding the mod function over there, so I'll take up that one as well. But before that, let me clarify something regarding the transitivity. Okay, last time it was quite a lot of confusion regarding because in the particular. Yes, video is too hazy for me as well. While today possibly net is not working fine. I have to wait for some time. The other network also showing not a very nice video. Just hold a moment. Let me just try and see how good or how bad it is actually. Okay, let me see. Join. Let me see. Join. Okay, at least on the mobile phone it looks. Oh, sorry. On mobile phone it looks not so bad, by the way. But in laptop or desktop it will not be very crisp. Okay, because the connectivity actually. A lot of echo going on, and there's echo as well. So I'll just we'll have to wait for some time. Hopefully, if you're not getting things up, you can speak. Little stable. It will happen after some time, maybe. I do not know who's. It's obviously if everybody is getting a problem, that it has to be my network over there. Okay, but hopefully it is going to be okay after some time. Let us hope so. Yes. Okay. What I was saying is, last time there was a problem regarding the transitivity of a relation. Actually, we had some problem because in the book or in the assignment that I gave from a book actually some of the relations which seemingly were not actually looking transitive, but they were given to be transitive. You see, the idea is this: by definition, a transitive relation is what? It so happens that if it happens that whenever A comma B, A comma B belongs to the relation and B comma C belongs to the relation, then A comma C must belong to the relation as well. Then it must happen that A comma C must belong to R. Okay, that is what we know about. We know this is the meaning of transitivity. A relation is said to be transitive if it so happens that for every element in that particular set A, I mean, whenever A and B are belonging to the relation, which implies that A is related to B and B is related to C, then A and C should be related as well. If that happens, then we call this relation as a transitive relation. Okay. Now, some people, what they do, or some book basically, what they do is basically, if it happens, for example, that this B, the other pair is simply not present. Okay. If there is not, the other pair is not present, this part is simply absent. So we have only one of the pairs over there, and this part is absent. So this is definitely not required then. Okay. So if you have only one pair of elements present, but the other is not there, I do not have C present. I just have A comma B is there. B comma C is not there, and A comma C is not there. Okay. In that case, they call this relation, say, to be transitive because simply there is no contradiction to this. So they use a particular word. They call it something like vacuously transitive. Okay, something like related to vacuum, vacuously transitive. They basically, I hope this is the spelling. VACU. Just let me verify once. Otherwise, I mean, this is. Can you repeat? Yes, I'm repeating, Shubhankar. I was saying that last time there was a problem regarding the VACUOUSLY. VACUOU. Yeah, that's correct. Last time there was a problem regarding the transitivity. Yes, so the point is, if A comma B belong to R and B comma C belong to R, then A comma C has to belong to R. So if this B comma C is not there, if B comma C is not there, then there is no point in comparing. If B comma C is not there, in that case there is no need to look for the further definition or further checkup actually. If the pair A comma B is the only pair which is present and B comma C is not there, then there is no need to look further. It becomes transitive because there is no contradiction to what we have over there. Okay, there is no contradiction in this case, and therefore what we call this, not we but many people actually, not at least I am not in favor of that, but in some books it is written down. They take it to be vacuously transitive. Vacuously transitive meaning that it's transitive because there is no contradiction to the definition. Okay, so for that reason, for example, the empty set is going to be a transitive relation as well, because there is nothing to contradict the requirement actually. That is why they take it to be transitive. Okay, so I hope that is going to be clear enough. A comma B and A comma C are present, then you implies B comma C is missing. If A and B are there and A and C, so if AB is there but BC is not there, so AC is not required, but it is there, so there is not a problem. If on the other hand AC is present, yes, according to that particular definition, yeah, empty set is basically something which is there. Hold on a moment. If A comma B and A comma C are present there, but B comma C is missing. So let us look at the definition. A comma B is there, but B comma C is not there. So I do not need to check for A comma C, at least for the first pair. Similarly, A comma C is there, but C comma something is not there. So again, I don't require A comma B to be checked again over there. So this will be actually transitive because it is not, the second pair is missing. If the second pair is missing, there is obviously third pair, let it be, or it doesn't matter whether it's present or not present. I just require the presence of this second one. Only then we can just talk about the third pair. If A comma B is there but B comma C is not there, then I don't care about A comma C, at least as far as transitivity is concerned. It may be there, may not be there. There is no contradiction to this particular fact. That is what the point is. Okay, so in that case, Anik, you whatever relation you have given, A comma B and A comma C are present. In that case, I will take that to be transitive because of the particular fact that we are not able to contradict that. Okay, because A comma B is there, but B comma something is not there. B comma C is not there. So there is no point of comparison now because this requires only if B comma C is also present. I mean, if A comma B is there and B comma C is there, then we need to have A comma C to be present as well. If A comma B is there but B comma C is not there, then well, there is no need of comparison. Okay. So that in that case, I will take or then according to this definition that we have, the vacuously transitive relation, it will be taken to be a transitive relation. Okay? I hope that is going to clear it up. I mean, say this is not a very, I mean, at least it was not standardized earlier, but possibly people are now going to take it to be that way. So we shall take it this way. Okay, we shall take it to be transitive, even if it's vacuously transitive, implying that even if we do not, if I just do not get the second pair, in that case we do not have any contradiction to the definition, and that is why we're going to take it as transitive. So basically, if something is not transitive, it is transitive vacuously. Okay, is it fine? Well, vacuously antisymmetric, well, that is not there. At least I didn't find it out. Regarding transitivity is there, but vacuously antisymmetric, well, I do not think it's going to be there. Vacuously antisymmetric. Let me check. I do not have. Things have moved on. Basically, seems recently definitions have changed. Well, antisymmetric vacuously. No, it doesn't seem to be there. They seem to be there, by the way. But at least Wikipedia says so. We have to still check some literature over there. Well, basically, if something is not contradicted, it then becomes a vacuous truth actually. So if I mean, if something is not antisymmetric, in that case, I mean, if something is not, I mean, if the definition of antisymmetric requires Ankit, okay. AB and AC is there, then can't we say BC? No, no, Moinak, that is not correct, okay. If AB and AC are there, oh, if AB and AC are there, no, there's no need to say talk about BC, okay. If AB and AC are there, then BC, if BC is present, then we get this relation to be transitive, the usual way. But if it is missing, in that case, it is still transitive, vacuous way, okay. When it is not going to be not transitive is the fact that if AB is there and BC is there, but AC is not there. That is what the point is. It may happen that A, B are identical. That is a possibility. But if A comma B belong to relation and B comma C also belong to relation, but A comma C is not there, only in that case it is going to be not a transitive relation. Okay, that's the only thing we have. We know when it is not transitive. In every other case, it is transitive. I said so, Shubhankar, that you have to just verify whether it is not transitive. Okay, in order to do so, you check for AB and BC. If AB is present and BC is present, but AC is not present, then it is not transitive. In all other cases, you have to take it as transitive. If it happens that AB and BC both present and AC is, then A comma C is present, then it's going to be transitive the usual way. But if, say, for example, B comma C is missing, it becomes transitive vacuously, which implies it becomes transitive without any due to no contradiction actually. Fine. Yes, the same thing. If we are not able, if we are able to kind of not contradict it, in that case it becomes vacuously truth. Fine. If you are not able to contradict a truth, it becomes a vacuous truth. Fine. I mean, there is no, I mean, for example, well, if I am not able to kind of justify a certain fact, or at least we are not able to contradict that thing. If we are able to contradict, it obviously becomes wrong. But I am not able to establish a truth. But again, I am not able to contradict that particular statement as well. Okay, I'm not able to contradict, but I'm not able to. Sorry, I mean say that I'm not able to prove it, but I'm not able to contradict that statement as well. Then it's becoming a vacuous truth. Fine. So unable to prove, but unable to contradict as well. That is what it means actually. A symmetric relation actually implies if AB is present, then BA must be present. That's the idea. If AB is present, then B comma A must be present, and that must happen. That must happen for A and B, even if they are identical. Actually, fine. Antisymmetric implies that A comma B and B comma A are going to be present simultaneously only when A and B are equal, which implies that if A comma B and B comma A both are present and A is not equal to B, in that case it is definitely not antisymmetric. Is it okay? It will be then becoming symmetric. If A comma B is there and B comma A is there and A and B are distinct, in this case the relation is symmetric and this is not antisymmetric. Okay? Yes, Nilabrata, it seems to be so. Every single pair of element. Yes, if you take a set relation containing only one pair, yes, then it becomes vacuously transitive. Okay, is that clear enough? I hope so. That's going to be clarifying things up. We have to actually take this particular definition because nowadays this is a thing which is in vogue. Actually, people are actually following this particular idea. Yes, Shivankar. If only AB present, then it will be antisymmetric. Well, because if only AB is present, but BA is not there, so it is not symmetric. Reflexive, just wait. Only A comma B is present, then will it be antisymmetric? For antisymmetric, what do we require? If AB is there and BA is there, then A must be equal to B. So if A comma A is the one which is present, then it becomes antisymmetric actually. If AB is present only, in that case, it cannot be said to be antisymmetric. But if AB is the only element present, but BA is not there, in that case, it actually is not symmetric either. If A and B are equal, in that case, it will become antisymmetric. Okay. Qadeep, then can we say that a reflexive relation be antisymmetric? Reflexive relations, yes, they are antisymmetric actually. Actually, every antisymmetric relation is not reflexive because if I have only A comma A present, for example, but say capital A contains two elements, capital A contains A comma B, I mean A and B actually, A and B, and the relation R contains only one pair, A comma A, then this relation is antisymmetric, but it is not reflexive. So yes, if it is reflexive relation, it has to be antisymmetric. Okay, reflexive implies antisymmetric, but antisymmetric doesn't imply reflexive. Okay, and what is this? Sir, can other elements are also present with AB? Then it is not. Yes, no. I mean, say you see that if AB is there and some other pair is there, BC is missing. In that case, it becomes vacuously transitive. Okay. All I'm saying that if AB is present and other elements are also there, but BC is missing, in that case, the relation is going to be vacuously transitive. Is it fine? All reflexive are not antisymmetric. Well, I mean, we just said, and Vesha, I believe, yeah, all reflexive relations are actually antisymmetric. That's what I was saying right now. All reflexive relations are antisymmetric actually, but all antisymmetric relations, they are not reflexive. Okay, Antisymmetric implies AB and B are present together only if A and B are equal. Implies basically you have pairs like A comma A. A comma A is there and other elements also there. A comma A is there, B comma C is there, but E comma A has to be there. In that case, the fact is B comma C and C comma B are not simultaneously present. But A comma A is there, which implies A comma. I mean, so basically, we have an antisymmetric relation because we do not have like AB and BA both present and A is not equal to B. That's not happening. So that is therefore going to be an antisymmetric relation. Okay. Anvesha, I believe that is what we have. Reflexive relations are therefore going to be antisymmetric by definition. Okay. Reflexive relations are going to be antisymmetric.
But if we have a means that A is equal to 1,
The voice is not very clear, Anvesha. Can you repeat?
relation. Sir, if we have a set A is equal to 1, comma 2 and the relation R is defined like 1, comma 1, 2, comma 2, 1, comma 2 and 2, comma 2, then this relation is reflexive, but it is not
1
antisymmetric.
comma 1, 2 comma 2. Oh, yeah, that's correct. Yes,
1, comma
you are
2.
correct. I was missing the other part. Exactly, that's correct. In fact, it is true. It has to be an identity relation actually. It has to be identity. If we get, for example, 1 comma 1, 2 comma 2, like in this case, A comma A and B, B comma B is there, but we also have AB and BA, then obviously it is symmetric, not antisymmetric. Okay? Yes, that's correctly pointed out, Anvesha. That is right. I overlooked that particular fact. For example, this particular relation is indeed reflexive. Huh? So that is correct. In fact, I mean this particular relation that we have written down over there, A comma A, B comma B, A comma B, and B comma A. This relation is actually reflexive, but it is not antisymmetric. So yes, that is correct actually. Pradeep, so that should be clarifying things up. Rishabh, what are you saying? In the net, it was given a definition which I wrote above. What I have written down, Rishabh? In one definition, it is saying that if B is in R, given A not equal to B and B A not in R, then there is antisymmetric. Well, that is for checking it is not antisymmetric. The point is that if AB and BA are both present, that will only happen if A is equal to B, okay? Then it becomes antisymmetric. Implies AB and BA, if they are both present, there must be only a situation when A is equal to B. Implies basically that A comma A is there. But if I have AB and BA both present, where N, B are not equal, then it becomes symmetric actually, okay? It is not then antisymmetric, okay? So basically the relation will be antisymmetric. You should not think of antisymmetric as the opposite of symmetric actually. That is not a correct way to think of it. The idea is that if it is going to be symmetric if AB and B are both present and A is not equal to B. But if AB and B are both present but A equal to B, in that case becomes antisymmetric. Yeah. AB is in R given A not equal to B and B A not in R. This is antisymmetric. No, that is not Rishabh. The only way to check whether something, I said already, if the condition is not fulfilled, it becomes vacuously true. So if the condition for the antisymmetric relation is AB belong to R and BA belong to R, that implies that A is equal to B. That's what it is. So if that definition is, if you're not able to contradict that thing, that becomes vacuously true. You're okay? What you have written down is, I don't think that's okay. I have, for example, A comma A is going to be just the relation A comma A is antisymmetric. Is okay? I hope that should be clear enough. So the more you think about it, the more you get confused right now. Right now it is first of all not required, and hopefully things will later on improve. Stick to definition, that's what I would like to say. Stick to the definition. Anything which is not according to definition, in that case going to be not what we're looking for. Relation which is not symmetric is definitely no. We can't say that. We cannot say that, for example, we require what? A relation which is not symmetric. This is symmetric, but this is, well, this is becoming antisymmetric in this situation. We would like to have a relation which is, well, you see, if something is not symmetric, it will then actually, even if it is not antisymmetric the usual way, it will become vacuously antisymmetric actually. So it is going to be there actually. Why not? What is reflexive relation? Reflexive relation is something where for every element in the set A, capital A comma A, basically this one is reflexive. It has to contain for each element in the set capital A, each of this, I need to have every element related to itself. Okay, if every element is related to itself, it becomes a reflexive relation. Fine. For example, a relation between, for example, A is a friend of B, for example, that is a friend of, that relation is going to be reflexive, at least that is what I believe. If A and B are friends, obviously A is friend of B and B is also friend of A. Uh, yes, you could say that, but Suleksha, I mean, the identity relation, for example, does not involve this. This one, for instance, is not identity. Yes, but a subset of the reflexive relation. Yeah, that's correct. Okay. This relation is, for example, reflexive. Why not is that okay? Because we notice that A is related to itself, B is also related to itself. That is what we want. This must happen for all elements of the set A. Okay, like A and B both, it should happen. If it is not happening for any one of them, it is no longer reflexive. Okay. In this case, for example, if I remove one of the, say for example, B comma B is missing, in that case it is no longer, it's no longer reflexive actually. Fine. What about AB? AB implies this. Okay, that may or may not be present. I say at least every element over here, they should be related to themselves. Everything else, they may or may not be there. Okay. We need to just make sure that at least for every element in the capital A set, each element must be related to itself. Fine. Apart from there, whatever other things are there, let it be. Doesn't make much difference. But at least those must be there. Okay. Okay. Somebody. Yes. Okay. Should I move ahead? The only thing you keep in mind that if you are not able to contradict a certain truth, it becomes vacuously true. Fine. That's what the idea they are following nowadays in logic. Arunago has left. He just sent me a message. Tomorrow I was okay. Just forget about tomorrow. Last time actually we were talking about some inequalities, and just hold on. Where's my pen? We had discussed about the inequalities involving polynomials, and we also looked at the rational expression. We dealt with inequalities involving rational expression. The only thing assignment that I gave, is it homework or last just now the questions? Yeah, you should just try it. No, not now. You can do it later on. Fine. Right now we just do some more things, and then you can just take them out. I mean, if your answer is not matching, then we can discuss it up. You're fine. Otherwise, we just take it to do it now. Then it's going to be just waste over there. You can just sit and do it yourself. Whatever you're not able to do, then we shall discuss about it. Right now, I would like to take up a few more inequalities. On it, regarding tomorrow's test, I will upload the question paper, and I will just try to make it so that you can take your exams anytime you want. But you have to make sure that you have joined the classroom, by the way. I would ask if everybody has joined the classroom, because I'm going to require the email if I have to make it doing those things. Full marks, why do you care about that? Don't worry, you'll just get it tomorrow, okay? Yeah, maths test, I'll just take it after that one. Maths test, I'll take it after that one, maybe on Tuesday or Wednesday. I have to prepare the paper as well. Okay, I have also a couple of test papers to prepare for the class 12 guys, so it'll take some time, okay? But after that, I'm going to take it up. Yes, Shubhankar, we were doing functions, but I said last time itself there was we are just going to take a diversion because doing the range and the domains of the function, for example, we require to take the inequalities. That is why I just took up the inequalities first, okay? Fine. I would like to consider one more kind of inequalities actually, that is the modulus function. When you have, oh my, not tomorrow, math test is not tomorrow. Tomorrow only physics test, okay? Math test is not tomorrow, fine. Okay, at least I hope that you have looked at inequalities when we have ratio of two things. I said already the usual trick to solve inequalities involving the rational function, a rational expression, is to make sure that the denominator becomes positive, okay? Once the denominator is positive, you could effectively uh, consider the numerator alone, and whatever will be the sign of inequality, that will apply only to the numerator here, okay? And then it will basically reduce to the inequality involving polynomials, at least so far. Later on we shall see that uh, your name is I am seeing it's written Momita. Can you tell me your name? I do not think that is your name. Uh, okay, it's not coming up. Oh, so hard. Well, it is just the first topic, by the way. If you want to give it a test, you can always give it. Otherwise, if you may leave it over there. And repeating again, I will send the test papers to the email IDs which have been given in the classroom. Okay. You will have to just, or better still, just do one more thing. Instead of, and people who are going to give the physics exam actually, you simply send me your email ID is in my WhatsApp, okay? It is there in the classroom, but in classroom there's a long list of people there actually, so I do not know who is in fact there so far. Some people might have left over there. So you just send your email ID to my personal WhatsApp, okay? I'll send the question paper only to those email IDs. Is it okay? If you are interested in giving the test paper, then you can do that. Otherwise, if you're not interested or you're not thinking of bunking the test, that's okay. Not here, Nilabrata. Do not do it over there, okay? This chat will be saved, but I will not consult this, okay? Just send it to my personal, that WhatsApp number, okay? Okay. Suppose first of all, let me define the modulus function once again. We already know by definition that mod of a certain quantity x is known to be something like x if x is positive, and it is equal to minus x if x is negative. That is the definition. That's the definition of the mod function, okay? So this technically is speaking of function, and we remember what we define the function as. Right now we don't actually require that. However, we should always remember that mod x geometrically gives us a distance of the point x from the origin. If I think of the real number x lying on the real axis somewhere, that's the real axis. If I say, for example, x is located over there, that's the origin, then mod x actually represents that particular distance. This is mod x, the distance of x from the origin. In a similar fashion, if x is somewhere over there, x is still a real number and x is lying somewhere over there. Let's say this one is x1, for example. x1 is a negative number, so mod of x1 becomes that particular distance. That is mod of x1. This will also give us a positive number, okay? So it's quite obvious by this particular consideration. If I consider the modulus as representing the distance of the number x from the origin on the x-axis, in that case it is quite obviously going to be positive. You'll find. And by definition, we have this thing over there. We can actually draw the graph of this function. Graphically speaking, I can draw the graph by looking at what happens on each of the sides. in effect, we notice that if I consider the xy plane and I look at the function or the expression or the equality that y is equal to mod x. So I'm going to assign in this case to the y coordinate of the point the value of the modulus of any real number. So if I just take for example x equal to 0, I'm going to get y equal to mod 0, which is 0 itself. If I take for example x equal to 1, I'm going to get mod x also as 1. So I have in this case this way. If I take x equal to root 2, I'm going to have mod x also root 2. On the other hand, on negative side, if I put x equal to minus 1, I'm going to actually get a plus 1 over there. So which implies for this minus 1, I actually end up getting a point over here, plus 1. In fact, if I divide the entire real axis using the point where the modulus becomes 0, okay, if I just divide the x-axis by using those points at which the mod becomes 0, then I see that mod x becomes 0 at x equal to 0. Therefore, we have to have a piecewise definition for x positive. If I just stay on the right side of the y-axis, then I notice that this is nothing but x itself. So the equation now becomes y equal to x. So I get y equal to x over there, which implies we have a straight line through the origin. Y equal to x implies y. That becomes a straight line. Y equal to mx plus c is a straight line. So which I was saying in this case that we could effectively look at the points where the argument inside the modulus is 0, that is this quantity is 0. If it happens that x is 0, in that case mod x becomes 0, and that is a point which will divide the real axis into different parts. I just need to consider x positive and x negative. For x positive, the equation is same thing as y equal to x. For x negative, the equation is same thing as y equal to minus x, because x is negative. So y equal to minus x is a straight line, which in fact has a negative slope like this. As a result of which, if I look at the mod function, that will be nothing but a combination of both these lines. It will become in this case downward slanting on the left side and upward slanting on the right side. That becomes a graph in this case of a mod function. Yeah, it will be a V-shaped graph. That will be, yes, correct. In a similar fashion, if I consider y equal to, for example, I take up y equal to mod of x minus 2, for instance. If I take up y equal to mod of x minus 2, in this situation, I'll have to look at the point x equal to 2. That becomes in this case the corner point. X equal to 2, the entire argument becomes 0. As a result of which, this is the point I'm going to consider as a point which will divide the real line into two regions. One is x more than 2, the other one is x less than 2. For x more than equal to 2, we get simply x minus 2 as a positive number. Therefore, the mod of x minus 2 remains x minus 2, and it becomes y equal to x minus 2 on the right of x equal to 2 actually. So x equal to 2 lies somewhere over there. 1 is there, 2 is there. So on the right of x equal to 2, this graph is coinciding with the equation y equal to x minus 2, which is nothing but a straight line having a slope of 1 and intercept of minus 2. So it should have gone something like this. It should have gone like this, but I require only that part which is on the right of 2, because left part is a different definition. I just take the right part, so I just remove the left part over there. Similar fashion, if I take up x to be less than 2, on the left of x equal to 2, this region over here, this region, x minus 2 is negative. So by definition, mod of x minus 2 becomes minus of x minus 2. So for x less than 2, y is turning out to be minus of x minus 2. But minus of x minus 2 becomes 2 minus x, or minus x plus 2 actually. This becomes minus x plus 2. Minus x plus 2, that is basically having a straight line with a negative slope, slope equal to minus 1, and intercept equal to 2. So that should have gone in this fashion. There is 2 over there. It should have gone like this. That is, this line should have gone like this. The slope is minus 1, and the y-intercept is 2 units over there. However, I require only that part which lies on the left. Therefore, I just remove this portion over there, and therefore I'm left with something like, again, a V-shaped curve, but slightly shifted. It's going to be V-shaped curve, but it is going to be shifted to the point x equal to 2. Is it okay? Usually, that is what I need to do whenever I encounter the mod. If I'm just going to obtain mod of something which is a product of many factors. Say, for instance, I consider I need not do the graph right now. I'm not talking about the graph. I was just talking about inequality involving only one variable. So far y is not there. I'll come back to that in a moment. What happens if I have an equation involving both x and y in mod? But right now, say for instance, I have a expression which involves a product. Say for instance that I'm going to consider in this case something like mod of x into, well, that will become, yeah, let's see, mod of x into x minus 2 is, say for example, more than equal to uh, or I'll have to just change. Let us consider something else. Say for instance that I have mod of x minus 2 more than or equal to x, for example. An inequality like this: mod of x minus 2 is more than equal to, hold on, I'm going to that. I'm just saying I'll come to the graph in a moment, but let's say consider an equality which has only one variable x for the moment. Okay, there's no other variable involved in this case. See here we have obtained something like this. We have got in this case mod of x minus 2 more than equal to x. The question is, what is going to be over here the required solution set for this particular inequality? Now, to obtain this particular thing, we first of all, as usual, break this entire inequality into two parts. One where we have the mod positive, the other one when we have the mod negative. In this case, because the quantity inside the mod is x minus 2, so the turning point, the corner point in this case, that becomes x equal to 2. So we consider the x-axis divided into two regions. So we have 2 over there. So I'm going to look at the x-axis divided into two regions. One which is to the right of the point x equal to 2, the other one to the left. If I go to this side, or rather, first let's look at this side. I notice on this particular side, because x is more than 2, therefore x minus 2 is identically becoming x minus 2. Mod of x minus 2 simply becoming x minus 2. Therefore, on this side over here, the inequality is identical to x minus 2 more than equal to x. However, that gives us a null inequality because it will never happen that x minus 2 is going to be more than equal to x. Okay, this gives us therefore no solution at all, because this will end up giving us, if I kind of cancel out x, that will give us minus 2 more than equal to 0, which is wrong, which implies at least for x more than 2 this inequality can never be fulfilled, which implies on this side there is no real number x satisfying this particular inequality. This is basically giving us a null relation. X belongs to the empty set in this case. Okay. On the other hand, if I just come to the other side, if I just again repeat, well, Devjyoti, I was just saying how to deal with inequalities involving only one variable, x, right now. If it contains a mod, okay. I was saying that whenever inequality contains the modulus expression, what I need to do in this case is we need to break the entire real axis into different parts with the points which are making the mod 0 dividing or becoming the boundary for those parts actually. Fine. I would just like to effectively figure out the corner points, which would be when the quantity inside the mod turns out to be 0. In this case, for example, if I look at mod of x minus 2 more than equal to x, then I just consider again, because mod of x minus 2 becomes 0 at x equal to 2. Therefore, I effectively look at the point x equal to 2. The right side is one region, the left side is the other region. For the right side, I notice that x minus 2 is simply becoming, mod of x minus 2 is becoming x minus 2 because mod x minus 2 is positive. And so this side inequality simply transforms to this, x minus 2 more than equal to x. But this is in fact giving us a null relationship because we cannot have x minus 2 more than x ever. Or if we just cancel this x out, I am going to get minus 2 more than equal to 0, which is wrong. That implies this will not be true for any x actually, fine. And therefore, when you just come to the left side, on the other side, x minus 2 is going to be negative. So for this side, the inequality turns out to be something like 2 minus x more than equal to x. Okay, because in this case, we get minus, the mod of x minus 2 becomes minus of x minus 2, which is implying 2 minus x. But that is going to give us in this case 2 is more than equal to 2 times x, which gives us x to be less than equal to 1. Okay, that is what we get over here. But by obviously we have to take the intersection part over there. I have already taken the x to be less than 2, so to further take x to be less than equal to 1, as a result of which the solution set over there is all real numbers to the left of the point x equal to 1, including 1. Okay. In fact, if I can check, if I put x equal to 1, I get 1 minus 2 is minus 1, the mod is 1, which is equal to 1. Okay. So it is equality is holding over there, but for every other point, the inequality will hold. Okay. So this becomes, in this case, a solution set. It's obviously a very simpler expression that we had. But the point is that even if I had a more complicated thing, left side, this one is basically saying 2 minus x. I am just considering what happens to this mod when x is less than 2. When x is less than 2, then x minus 2 is negative. Therefore, mod of x minus 2 becomes 2 minus x. So you get 2 minus x more than equal to x. The inequality, it transforms to this particular form. That is the form which now takes. It has become in this case 2 minus x more than equal to x on the left side. This will basically solve, we can just solve this easily. We get in this case 2 is more than equal to 2x, giving us x less than equal to 1. Okay, so that is what we have, x less than equal to 1, and we already have assumed that x is less than 2 over there. So the common part is x less than equal to 1. That becomes therefore the required solution. X in this case has to belong all the way from minus infinity to 1. Yeah, we could definitely do it with graph as well, Nilabrata. You can definitely do it with graph. And any inequality you can handle with graph if you know the graph over there, fine. If you're able to draw a graph, then it's obviously useful to look at the graph as well. In this case, for example, I can just draw separately the two halves. The left hand side, I can draw the graph of y equal to LHS, and I can draw the graph for y equal to RHS. So if I just consider in a graphical fashion, then I see that for the two sides, y, if I just consider, will depend, Nilabrata, how fluent are you drawing in graphs, by the way. If I, this point, the graph is quite simple, but obviously it will not be as simple always. In this case, for example, mod of x minus 2, the graph is known to us. It is nothing but a V-shaped curve, which is like this, for instance. 1, 2, like that. That is the graph for y equal to mod of x minus 2. Y equal to mod of x minus 2. That is the graph that we have. On the other hand, if I look at y equal to x, the right side, other condition did not give a null set. Yes, yeah, that is what Ishan. Oh, I mean, in this case, it is not the intersection but the union actually, because we were already doing two independent or two distinct regions. In fact, those regions x more than 2 and x less than 2, they're already they're already I mean say disjoint. So we not. It's actually like this. It is either more than 2 or less than 2. So we have to just take an or, which implies we have to take the union actually. Fine, not intersection. Intersection take you get null because they do not overlap. Okay. In this case, the right side the graph is y equal to x. So y equal to x is a straight line through the origin like this. Now I need to just figure out, because I require the left hand side to be more than or equal to right hand side. It means therefore, oh, how am I plotting the graph? Well, at least for the mod function I just said so a moment earlier, if I consider the mod of x, y equal to mod x, the graph was what? Like a V-shaped curve. I said that for x more than 0, the equation is y equal to x, which is a straight line through the origin. If I just take a x negative, I get y equal to minus x, which was again a straight line through the origin. So, HR, did you got that part, that when we do the graph for the mod function over there? Were you present at that time? At least it was okay. Oh, yes. So what I have done in this case is, whenever I have basically taken up the graph for each of the sides, y equal to LHS and y equal to RHS. The fact is I'm looking for LHS more than RHS. I'm assigning the values of the expressions. I'm explaining that. I'm assigning the values of the expressions to the y coordinate. Okay. I'm assigning the values of the expressions to the y coordinate. Therefore, in this case, for example, when I just draw the graph for y equal to mod x minus 2, I'm going to get a V-shaped graph but the corner point is going to be x equal to 2 because it's mod of x minus 2. That's why the graph is like this. What I'm doing is whatever value I'm going to obtain for mod of x minus 2, I assign it to the y coordinate. Okay. Well, you apply the definition Moynihan. It turns out that whenever you just talk about mod of any quantity, not only x, mod of any quantity q, if I have whatever inside a modulus, you just need to take up when is that positive and when is that negative. Okay. In this case, I look at when is x minus 2 positive. So x minus 2 is positive when x is more than 2, and negative when x is less than 2. So 2 in this case is the corner point. Okay. It has simply shifted over here. Anushka, what is saying in the previous process on the number line, why do you take the point 1? Well, we solved for it by the way, and it was an unequal, more than equal to part was there actually. Anushka, it was more than equal to. That is why you consider equal to as well. A value of x to well, no, Sveksha, it is not like that. Well, at least in the junior classes, you have to do that. In class 9, 10, for example, we're asked to plot the graph by taking values of x and finding the value of the y and so on. But now you should actually know this. Belong to no 0. You see, actually, we have to take the biggest possible thing. Okay, for what? I'm just talking about Sohar. Sohar, it is actually when I have to solve an inequality. In that case, for example, we solve to get that x was turning out to be less than equal to 1. So obviously minus infinity to 0 will be a part of it. So it will actually be true for those numbers as well. But in this case, it can be also true for more than that. Okay, till 1. So I have to take everything over there. Fine. Yes, hold on, Ian. I'm just going to that. But Sveksha, if you consider how am I going to draw the graph in this case? Because we are going to get every time a linear equation. I said we are going to have something like this. For example, when I take on the left hand side, I'm going to assign the y coordinate to this value. Okay, which implies I'm going to assign whatever value I get of this number, this expression, I'll assign that value to the y coordinate. So for example, what graph I have drawn from the blue line actually is the graph of this thing, y equal to mod of x minus 1. Now you obviously can take up values to draw the graph, but we do not require this, okay? Because the mod function is in fact a piecewise function. Notice that whenever x minus 2 is positive, if I just rub it up, and notice in this case this is equivalent to, by definition of the mod quantity. I said mod of anything or mod of any quantity that we have to take up the quantity to be q itself when that q is positive. So whatever is inside the mod, if it is positive, then the mod of that thing is simply that number. In this case, x minus 2 is positive when x is more than 2. Therefore, x is more than 2, then this is simply y equal to x minus 2, which implies the right side now becomes simply x minus 2 if x is more than equal to 2. On the other hand, if it happens that x is less than 2, then mod of x minus 2 will become minus of x minus 2, because when x minus 2 is negative, then I have to put a minus sign in front of that to get the mod. Okay, remember mod of x was minus x if x is negative, and something like this. If I consider mod of minus 1.5 for example, I notice that because minus 1.5 is negative, so its mod will be minus of minus 1.5, implying minus of minus 1.5. That's what it means, but that is going to be nothing but 1.5. Okay, so in a similar fashion, if I just consider the region where x minus 2 is negative, which will happen when x is less than 2 actually, in that case, mod of x minus 2 will turn out to be minus of x minus 2. So therefore it becomes minus of x, minus of minus becomes plus 2 if x is less than 2. Thus we have. Now think of these equations as lines. I mean, say for example, I look at this, when I have x more than equal to 2, then y is equal to x minus 2, but y equal to mx plus c is what, by the way? What does y equal to mx plus c represent? It's a linear equation. Why is it called linear equation? Because it represents a straight line. Okay, and because it represents a straight line, and a straight line is determined uniquely by any 2 points on it, so there is no point in finding many points. I can just figure out a couple of points, only 2 of them. In fact, I just find only 2 points, and we join those 2 points, and that is the required graph. Okay, so y equal to x minus 2 I considered, y equal to x minus 2, You notice by you can just compare the equation which we know, y equal to mx plus c. I hope you have read about it, by the way. I think in class 10 there was linear equation chapter when we had the equation of a straight line, y equal to mx plus c is a straight line. Yeah. So in this case, y equal to x minus 2, m is 1, a constant number, 1, and c is minus 2. Therefore, this is a straight line having a slope of 1 and intercept of minus 2. Therefore, I have just drawn a slope of 1 and intercept is minus 2. So if I had drawn the entire line, it would have gone down and intersected the y-axis at the point y equal to minus 2. But I have to just take only that part which is to the right of 2. Therefore, I remove those little that portion which is on the left side actually. Fine. Similarly, on this side, if I just take other definition, y equal to minus x plus 2, there's a downward slanting line. Intercept is 2. It was like this. Again, I remove that part which is to the right of 2. Is it okay? That gives us in this case this mod function. Same question as IL. Yeah, hold on a moment, hold on. In this case, in order to write down the solution, what I have to do is I have to consider when is the blue graph above the red one. Well, it's not visible which is blue, which is red, by the way. The blue is a V-shaped curve, okay? I want in this case for what values of x is a V-shaped curve above the straight line, which is this one, passing through the origin. That is what the right side was actually. Okay, fine. The right side was actually this one, y equal to x, and the left side was this V-shaped curve, which is y equal to mod of x minus 2. Fine. We require the regions where the blue part is above the red one. Okay. Now you could see, for example, this particular point is the intersection point, and you notice that to the right of this intersection point, the red curve is above the blue one. Okay, that is I don't want. I want the other half where the blue one is above the red one. Therefore, I require basically all real numbers to the left of this point. This is the point I'm looking for. I just want all real numbers to the left of this point, right? But this point can be easily figured out in this case because this is nothing but the intersection of this line and this line. Notice this line is nothing but y equal to x, and this line that is equal to this one, by the way, y equal to minus x plus 2. That is the second line. So I have to just equate them. I get x equal to minus x plus 2. But that gives us 2x equal to 2, giving x equal to 1. This point is therefore x equal to 1. And that is why in this case we consider all points to the left of x equal to 1. Okay? Yes. To a solution there to, yes, actually that's correct. Oh, no, inequality is not required, by the way. Or if you require to have a solution, then definitely the two equations must intersect. But for an inequality, that's not required. Okay, for an inequality, it is not required. How I got the red line? The red line is nothing but the right side. Right side was y equal to x. What is y equal to x, by the way? So hard. What about? Okay, it's not. What is the name? I'm seeing Tapti Chakravarti. So can you tell me your name, by the way? I know it's not yours. Monak as well. Okay. How I got the red line? Because if you look at the right side, tilted. So how one line is above? I mean the y coordinates. When I just consider is above, it implies okay, Somnath. I'm just going to consider the y value actually. Okay, the y coordinate. That is the one we have to compare. I'm just, you can see because originally what we have plotted y equal to something. I have assigned the y coordinate the value of that particular quantity. Okay. So when I compare, so say that y is equal to q1 and y equal to q2. Now I want q1 to be more than q2. So what we compare? We're comparing nothing but the height, the y coordinates. That is what we're doing. Okay. Why do we take y equal to x line? Why do I consider y equal to x line? Why? Because the right side was equal to x. So I have assigned the value of x to the y coordinate. So that's why I'm going to take y equal to x. Okay. Basically, I'm going to take up y equal to LHS as one equation, y equal to RHS as the other equation. And I just need to consider in this case when is the y coordinate of the LHS more than the RHS. So I'm just looking at which graph has a bigger y value. Okay, that's what I'm looking at in this case. How heights are different, that's for you to see, by the way, because for example, for this red curve, at any x, I'm just point is that we have to just compare that for every x. Okay, for a given x, just compare the heights. In this case, for example, That is the height for the red one at this particular x, while the height of the blue one is over here. So it's quite obvious which is more, by the way, isn't it? Right? For the other side, if you consider over here, for instance, the blue one is below. Blue one is this height for this x, while the red one is actually at the same x, red one goes up, which implies red is above. Okay? Is it fine? Any other doubts that we have? Anik, why do it? Okay, fine. Or how somebody asked how I draw the red curve. Well, I have plotted y equal to x. Okay, y equal to x is what? A straight line through the origin at 45 degrees. Y equal to mx plus c. C is 0, m is 1. Okay? Is it fine, everyone? Okay, in that case, I should move ahead a bit. Let's take a bit more, a bit difficult one. These were all linear curves. Okay. Hold on, by the way, just before moving ahead. Yes, Sureksha. Orkodeep, why? Y implies y. Orkodeep, what is meaning of y? Uh, Orkodeep, can you repeat what is the meaning of y? Why do we take y equal to x line implies? Anik, again. Why we have taken the y equal to x line? Well, you remember inequality. The inequality was like this: mod of x minus 2 more than equal to x. That was the inequality that we are solving. This is the inequality solving. So this is the LHS. That is the RHS. So what I'm going to do is, if I want to take the graphical mean or graphical means to solve it, I'm going to assign the y value of the questions. Well, I'm going to consider the value of the LHS, whatever I find for the particular x. For example, I put x equal to minus 1. So I'm getting value as minus 3. Mod of minus 3 becomes plus 3. So I get plus 3. I will assign that particular plus 3 to the y coordinate. To take a point which is x equal to 1, minus 1, y equal to 3. Is it okay? So I'm going to take up, because I wanted to solve in this case a graphical way, that is why I'm doing this, otherwise not required, because I need to have graphs. So what I'm going to do is I'm going to consider the graph of y equal to LHS and the graph of y equal to RHS. Okay? Yes, that's what the point is. I was just talking about the original inequality actually. Okay? Why I took the point 1 in the method? Well, because that is what we got, in fact. Okay, Arkadev, now it is okay. Now, brother, hold on a moment. I'm drawing that graph, don't worry. Just a moment. Why I considered x equal to 1 is the fact that that is what I obtained the solution as. Okay, you see that for x less than equal to 2, or less than 2 over there, for x less than 2, x minus 2 is negative. Therefore, mod of x minus 2 becomes minus of x minus 2. So far, I just applied the definitions. X less than 2 gives us x minus 2 negative. X minus 2 negative implies the quantity inside the mod is negative. And therefore, mod of that quantity must be minus of that quantity. Therefore, I get minus of x minus 2, which is nothing but 2 minus x. Okay. So, therefore, for the region x less than 2, for this region particularly, for this region, this inequality now becomes 2 minus x more than equal to x. That's what it becomes. This is only true when x is less than 2, otherwise it won't be. Fine. Point is that whenever you encounter the mod, you simply break the entire real line into different intervals. In each interval, and what intervals you're going to get will be determined by those breakpoints, those points at which the quantity inside the modulus becomes 0. Okay? In this case, for example, I end up getting this, but this one gives us what? 2 more than equal to 2x. I just take this x on that side, it becomes twice x. And therefore, I have 2 more than equal to 2x, but that is going to be when? That is becoming when 1 is more than equal to x. 2 is a positive number, I could cancel it out. So ultimately, I'm left with x less than equal to 1. That is why I considered x less than 1. Anushka, you okay? It is what was a solution actually. Fine. Okay. Yes, I will do it. If not today, maybe tomorrow. Okay. If I remember today, I will do that. Otherwise, I have to send it tomorrow. Okay. I'm going to send you a lot of questions of inequality. Just try them out. Okay. Yes, some theory as well. Okay, no problem. I just sent in theory as well. Okay, let's consider. Nilavrata has been asking for a long time. What about the graph of an expression which is y equal to mod x plus x minus 2 by the way. What about this particular graph? Y equal to mod x plus mod of x minus 2. I would like to draw this graph. What happens to this? Well, the idea is pretty simple. Just consider each of the mods. Okay, each of the mods. In this case, we have two mods present. One is mod of x minus 2. The other one is mod of x. So I just figure out points where each of those mod becomes 0. They will be the turning point. They will be the corner points over there. This mod is 0 when x is equal to 0. Well, yes, I said already. Whenever you take up the mod thing, okay, whenever there's something mod, it already is a piecewise expression. Okay, so it actually implies we're going to take up in this case. In this case, I'm going to just consider every point at which the modulus becomes 0 because those points will divide the real line into various regions, and each of the regions, the definition is going to be different. Okay, so the plan is very simple. You just consider different parts of the real axis and look at the points which are the corner point for each of the mod. Okay, and then we just look at those points. They will divide the real line into different intervals. In this case, for example, if I take this mod equal to 0, it becomes 0 when x is 0. This has a corner point of x equal to 0. This has a corner point of x equal to 2. These are the points where we have to divide the real line into different regions. Okay, so what I'm going to do is I'm going to just consider, for example, the x-axis, and the points which are going to divide the real line into different regions are these 2 points. So I'm going to consider 3 regions: x less than 0, x lying between 0 and 2, and x more than 2. In each of the regions, the expression will be different. Okay, in this case, therefore, if I consider because in this case the real axis will be divided by 0 and 2. So we have this side which is x less than 0, this side which is x more than equal to 0. So I have this part x less than 0. This part is x more than equal to 0 but less than 2. And this part is x more than equal to 2. Is it visible? Yeah. So I just consider each of the regions over there and rewrite the definition accordingly. For instance, if I take the region x negative, what happens? If x is negative, it is quite obviously that x is also less than 2. Okay. If x is less than 0, then definitely x is less than 2, which implies that x minus 2 is negative as well. So in this region, for example, both are negative. Okay, let me write down. I'm just going to consider in this case 3 regions for x less than 0. If x is less than 0, quite obviously x is less than 2 as well. Therefore, I get in this case x mod x equal to minus x, and mod of x minus 2 is also becoming minus of x minus 2 because they are negative. So I get minus x plus 2. So I add them up, and so what I get? I get minus x minus of x plus 2 gives us minus 2x plus 2, which implies I get minus 2x plus 2. That is happening when x is negative strictly. X is less than 0. Then I get this. Okay. Yeah, that is what we have to do, Ishant. Whenever you get a mod function, simply break it up into intervals. That's it. Okay. And in each of the intervals, take a different definition. So basically, one mod question will actually contain many questions in effect. And if I just take up this portion, x lying between 0 and 2, in this part I notice that x is positive. So at least this mod x is going to become x. But x is less than 2. So mod of x minus 2, line in mod x is equal to minus x. If x is negative actually. Mod x is equal to, can't see the extreme right. Are you looking at your mobile phone in landscape mode, by the way, or simply keeping it vertical? You can try to convert in landscape mode. Anyway, I'm just going to, okay, fine, I'll just rewrite down the entire thing over there. I'm just going to write down the whole thing again. What we have is this. I wrote down y equal to mod x plus mod x minus 2 equal to I said on that for x negative, well, x1 will be coming up in this interval, isn't it? Why not? So we just accordingly apply that. I and I repeating your question. The graphs are tilted, so how one line is above the other? I said that I'm going to just look at the y coordinates. Okay, the y coordinates, the heights. The height is what I'm going to compare. Okay. Okay, fine, no problem. Uh, Raini, you said how mod x equal to minus x. That is by definition when x is negative. If x is negative, which is in this case because I already consider x to be less than 0. If x is less than 0, then mod x is by definition minus x. Okay. I was just giving example. If say for example mod of minus 1.5 we have, then minus 1.5 is negative. So mod of minus 1.5 becomes minus of minus 1.5. That gives us plus 1.5. Okay. That is why in this case I have got mod x to be minus x. Okay. Now coming back, I said that in this case for this left part over there, for x negative, the definition turns out to be therefore minus x plus, I get minus 2x plus 2 if x is negative. Now is it visible, Tamogna? Yeah, so it is coming out positive, Raini. You see, mod x should always be positive, isn't it? Yeah, obviously it is positive. You notice that mod x, if x is negative and I take mod x to be x, then x becomes negative, isn't it? That is why I have to take a mod x equal to minus x if x is negative, because if x is negative, x is a negative number. So you must put a minus sign in front to make it positive. Is it okay? I said I consider, for example, minus of mod of minus 1.5, for instance. Mod of minus 1.5 is going to be what? By definition, mod of minus 1.5 becomes minus of minus 1.5. That is going to be 1.5, which is positive, isn't it? Okay. So that is what we have. You do not think that this x is a number is positive. It's not. It's actually a negative number in this case, and accordingly minus x becomes positive. Fine. Okay, so in this case, what we have? We have minus 2x plus 2 if x is negative. What if I consider in this interval x lying between 0 and 2? If x lies between 0 and 2, then x is more than equal to 0. Therefore, mod x is going to be is going to be positive. So in this interval, mod x becomes positive. This part becomes positive. It becomes x over there. Well, this is still negative. So this part we get what? In this region over here, in this part of the interval, we end up getting x plus 2 minus x, which is giving us simply 2, a constant. Yeah, that is what we have. So we get in this case simply 2 if x is positive but less than 2. Moinak, that is what we have. Oh, no. Anushka, it is not a solution. Right now, we have the solution y equal to 2 by the way. Okay, the solution is y equal to 2, which implies a horizontal line. And finally, for the last part, everything is positive. In the last interval over here, each of them is positive actually. And that is why we are going to simply end up getting x plus x minus 2. And therefore, for the last interval, it becomes simply 2x minus 2 if x is more than equal to 2. You notice in this case that the inequality sign that we applied, in this case we have strict inequality. There is no equal to sign over there. I have taken equal to sign to the next part, this one. So 0 is included in this interval, not in this, okay? 0 is not over there, 0 is over here. Simply 2 is not over there, 2 is over there, okay? So for this, these are 3 pieces that we have got. Now you can draw the graph, because in each of the sub part of the real line, each equation is going to be a straight line. We have, for example, x lying below 0, x negative, then like left of the y-axis, we have y equal to minus 2x plus 2. So we have y to mx plus c kind of thing. Slope is minus 2, the intercept is plus 2. Okay, so you can draw the graph now. What we have is this. The breakpoints are 0 and 2. These are the important points in this case. 0 and 2. So what happens for x less than 0? The equation is y equal to minus 2x plus 2. So y equal to minus 2x plus 2 is what a line. It has a slope of minus 2 by the way, which implies x equal to, if I just put x equal to -1, I'm going to get 5 actually. So the slant is basically going to be like this. It is that way. It is quite steeper compared to y equal to x actually. It's in fact passing through, if I extend it, it will in fact go through the point x equal to 1, because if I say to put x equal to 1, I'm going to get 0. So if I had extended this entire thing, it would have passed right through x equal to 1. But I only require that part for 0 the above to satisfy and for 2 the below to satisfy. Well, not below 2, but the last part actually. You have to be careful because in some cases there might be a break by the, okay. You might happen to find that the two parts will not match over there, okay, at that point. So there might be a break in that case. That is why you must be careful which side to take the equality with. Okay, Onik? Anyway, so I was saying that if I just had extended entire thing, extended this line, that would have passed through the point x equal to 1, but I only require that part which is to the left of the origin. That is why only this part remains. This is simply the part of the line y equal to minus 2x plus 2, which I have drawn. Yes, it is like a basket. Then similarly, if I just go beyond the point, or if I just look at between 0 and 2, between 0 and 2 the graph is simply y equal to 2. Y equal to 2 is a horizontal line like this. Okay, that is y equal to 2. And once we go beyond that particular point, x is more than equal to 2, then the graph is y equal to 2x minus 2. Now y equal to 2x minus 2 again have a slope of 2. The y-intercept is minus 2. As usual, for x equal to 1, it have been 0. So it have just gone like this from there till there, because I require 2 points in the graph. So because a straight line, x equal to 1 gives us 0, x equal to 2 gives us 2, which implies it should have gone that way. I need to retain only that part which is to the right of x equal to 2, and therefore I retain only this portion. That is therefore the required graph. That becomes the graph in this case for this entire equation. You should think of this is an equation, by the way. Though technically speaking, right now it is a function as well. If you remember, we have already discussed about a graph being a function. I said that if you can take the vertical line test. You draw a vertical line, just translate it along the x-axis, basically implying that you just draw any vertical line. It should cut the graph at most at one point. Then it's going to be a function. In this case, it is indeed, if I draw a vertical line anywhere, it will cut the graph at exactly one point, and that is why this is going to be a function. Okay. Had it been cut at 2, it was going to say, for example, intersected 2 points, it will not be a function. Is it okay? I hope it is fine. Huh?
Always the combination of two functions is a function.
Again?
So always if we take two functions, means the combination is that a function.
The summation, the sum.
No sir, like here we had taken the two different functions, that mod of x and mod of x minus 2. Now if we combine any two random functions like this, will it be a function? Always.
Actually, you see the voice is very echoing too much, by the way. Hold on a moment. I cannot get you because the bass is too much.
Sir, I am writing it.
That will be better actually. Elaborate, Monik, how do you guess the braces? Well, I explained the entire thing, by the way. I just added up this for these two over there. That's it. I just changed each of the mod in different cases. Each of the mod I changed it. Okay. I consider, for example, I already said when you just need to look at when will each mod become 0, and look at those points. They become the corner points. They become the turning points over there. You have to consider only that part. I just consider x equal to 0 because that is when this becomes 0. This will become 0 when x is equal to 2. So I consider those 2 points, 0 and 2. Each of the intervals I consider the value of mod to be different, and therefore Nandita, sorry, Anvesha. Actually, combination means what? Combination implies what? Combination implies a sum or a product or what? Sum. Yes. If the individual functions are functions, or the individual graphs are functions, actually, then somewhere it will be a function always. Because we know if I just consider sum of two functions, like fx and gx. I know that every x which have only one y for fx and gx both. So I have to just add up them, add the y coordinates over there. Okay. A sum of a function actually implying adding up simply the y coordinates in the graph actually. Is okay? Second, third one, Moina, the second part over here, I considered x lying between 0 and 2. If x lies between 0 and 2, then x is positive quite obviously. Therefore, this becomes simply x. Mod x is simply x. Hold on a moment, I'm just coming to that part over there. It's usually not very easy to plot rational functions because behavior might be very complicated, but in some cases, if the degree is not very large, we could still, the power of the numerator denominator both, they're not very large, we could roughly plot them. Okay, we cannot do exact by the way. Okay, exactly will not be always to be. I mean, for example, if I take a very complicated function, then apart from the computer, there's no other way to plot it. But we can just talk about a rough sketch that we can always do. Okay. Uh, let's see. Hold on, Moinak. Is it clear why I'm getting this particular thing over there, Moinak? Because when I consider this region 0 to 2, x is positive, so mod x remains x, but mod of x minus 2 becomes 2 minus x. Why? Because x minus 2 is negative in this interval. In this interval, x minus 2 is negative, and that is why mod of x minus 2 becomes minus of x minus 2, which is 2 minus x. Fine? And therefore, we end up getting x plus 2 minus x, which is 0. 2 actually. Okay, and similar for the last interval as well. Basically, just break it up. Simplify the entire thing by breaking up into lot of intervals. That's as simple as that. Okay. Okay, let's. Anvesha, I said I'll just take it up. Shubham, what if you multiply two mod functions? Well, what do you think about that? If you multiply two mod functions, you should keep in mind that by definition, mod of x1 into mod of x2 is nothing but mod of x1 into x2. Okay, which implies actually once you multiply two mod, you have to just multiply the quantities inside them. That might not be linear. In this case, for example, you multiply mod of x into mod of x minus 2. I actually get a inside the mod sign mod of x into x minus 2. That's a quadratic. Let's draw that one as well. Let us see what happens. Let's talk about the product and see what we get. Do you have any idea regarding quadratic expressions, by the way? You must have solved quadratic equations. You must have done that. Quadratic equations is known to, I hope, everyone. The quadratic expression themselves, which implies I'm going to consider the value of a quadratic expression, assign it to the y coordinate. That might not be so far done by you. Turns out that if let's look at the product by, let's see how it works out. Let's say that we have a product y equal to mod of x into x minus 2. Okay. I said already, by definition, it is true indeed that mod x1 into mod x2 is same thing as mod of x1 x2. That is what happened. This is a property of the modulus function. Okay, it's always correct. But you do not think that mod of x1 plus mod of x2 is equal to mod of x1 plus x2 by. That's not always correct. Okay. What do you think? What do you think about this? Mod of x1 plus x2. Can I write down this one as mod x1 plus mod x2? Can I write down like this always? What do you think? Will happen? No?
Sir, if x1, x2 greater than equal to 0.
What? 0. The board is hazy, Devjyoti. It's an internet problem. I'm just trying to speak up whatever I write down. Okay, that is nothing could be done for the moment. It's troublesome. Yes, I have written down in this case. What do you expect in this case? Will mod of x1 plus x2 equal to mod x1 plus mod x2? Are they going to be equal? They will be equal. Yes, that's correct actually. They're actually going to be equal if and only if they have the same sign actually. Yes, either they're both positive or both negative, only then they're going to be correct. Okay, otherwise they will not be correct. Anyway,
0 also.
uh, well, yes, my video is also very hazy. The feedback I'm just taking from. Let's see if I just connect to a different Wi-Fi by the. Yeah, Akash, you are having nice videos. Okay, but mine is a bit fuzzy, hazy as well. If it is a bit visible, then it is okay. Let me see if I can switch off the. I mean, switch the Wi-Fi. What I get by the way. Video is okay. Okay, Akash sitting under a tower. Okay, okay. So it seems that it seems that's good for. I do not know if you are looking at the video from a small screen or a big screen. On a bigger screen, there might be a bit trouble, but on a small screen of a mobile phone, yes. So is it coming a bit hazy, Suveksha? Mine was also a bit hazy today. The feedback one. I'm just using a different network for that. Just wait a moment. Maybe just I just switch my network. In that case, possibly I might get. Let me see if I get hazy, then I have to return back. Okay, net is gone for this part. No internet connected. Okay, let us see. Computer. Okay, let me see. It seems that this is also not very nice. Okay, Anushka, you are watching. At least the transmission part is okay. Probably my receiving part is not so okay. Yes, it is still coming a bit hazy to me, but let us see. You see, so what happens is broadband always doesn't work with the same speed as it has been projected. I mean, if it is advertised, if it's just saying 100 Mbps LAN, it is not going to give you 100 Mbps always. Okay, it will give you 100 Mbps if and only if you are the only user. Okay, if you're the only one who is using, normally what will happen is the cable broadband people, they actually share. Yeah, mobile. Okay, fine, no problem. Okay, mine has a bit. It has become a bit better compared to the previous one, but nothing to be done for the moment. Okay, let's continue. Yes, so that is a problem, Suveksha. If people are using video streaming simultaneously, then there may be a problem. Okay, mobile data is good for the small screen, by the way. It just projects something like 360p. 360 pixel size is the width actually for a mobile screen, and therefore it will be good for even at a mobile data speed. But if I use my mobile data to do it with a computer, it will not be giving us such clear picture. Okay, it requires more pixels in the computer. That's why. Anyway, there's hardly anything I could do about that right now. The only thing is that maybe if things are not clear, you can come back and look at the video later on. At least I'm going to just speak up whatever I write down. Okay. Let us consider the product in this case. Before that, let us. Yeah, that's correct. Minor. I take up a class in my Geo5 device by in one class, which is around 1.5 hours. Around 1.8 GBs are gone actually. Okay, fine. Yes, because too many. So everybody is going to take now online class. What to do? What to do? By the way, there's no other solutions right now. Okay, that is what we have to do. Anyway, uh, if I consider the product first of all, if I consider this one, again I'm going to utilize a definition. I just utilize a definition to write down this product into different parts. As usual, the breakpoints are the same, 0 and 2. Okay, they are the breakpoint that we have the last time. The same thing is now going to be still true. The breakpoint are those particular points. In this case, if I look at the definitions, at least for the moment, first of all, let's look at the definition. This will be therefore turning out to be when x is negative, when x is less than 0. I could share my screen if people are interested. They might get a picture which is a bit visible. See what you get by the way, and you can always switch if you do not like your view. That is what I'm looking at right now. Okay, I hope that is sharing, but right now it has become fuzzy. Uh, are you able to see my screen? No, now you're able to see my screen over there. Hmm. Now it has become a bit fuzzy. Yeah. It's no trouble. I'm not doing the hard work over there. The computer is doing the entire thing. Okay, then you switch back to whatever you were. Okay, just keep on looking at what we earlier had. Oh, I'm pretending my screen so it has become smaller. I want to have this bigger picture. It is not coming. Hopeless. Yeah, it has now come, but it is a bit hazy. But as long as it is okay, that's fine. Meanwhile, you can just change it. Well, let's finish it up this one over there. In this case, if I take up x negative, if I consider x negative, when I just take x negative over there, this side, as usual, like the previous thing you've got, the first part was negative, x is negative, and x minus 2 is also negative, as a result of which the product becomes positive. So therefore, in this case, the product is still the same, x into x minus 2, if x is less than 0. Why it happens? Because both are negative. X was negative and x minus 2 is also negative. Therefore, mod x becomes minus x, and mod of x minus 2 also becomes minus of x minus 2. Therefore, we are going to end up getting, in this case, the product as positive. I mean, say the sign remains plus, by the way, because minus into minus becomes plus. On the other hand, if I take up the region which lies between 0 and 2, this part, x is positive, this is negative. So mod x minus 2 becomes what? Mod of x minus 2 becomes minus of x minus 2. This is simply x. So now I get, in this case, minus of x into x minus 2. Okay, this is what I have done is I have simply multiplied the two expression. That's all. This is when x is going to be more than equal to 0 but less than 2. And once again x is more than 2, both are positive. So once again I get x into x minus 2 if x is more than equal to 2. And so we get basically the same expression or the same graph when x is negative or x is more than 2. So if x is less than 0 or x is more than equal to 2, the graph is the same, or it's just part of the same graph actually. But if x lies between 0 and 2, then the graph is a bit different. It's negative that. Okay. Now the point is, in this case, if you look at the graph, for example, if I consider this for this to y equal to this one, y equal to x into x minus 2. That is a quadratic expression actually. This is a quadratic expression. Okay. Now for the quadratic expression, you know what is a graph for a quadratic expression? It is no longer linear, by the way. Linear equation, the graph will be, for linear equation, the graph is going to be a straight line, but not for quadratic expression. For quadratic expression, the graph is going to be something called a parabola. Well, it's actually a basket-like. Yes, it is more like a basket, but it's also a bit straight. Okay, I mean, say it's going to be like a smooth curve, which is almost like a. If I just take up a rope, for example, and hold the two ends, it's going to be something like this. That is the shape almost. It is not exactly, by the way, almost. This shape, in fact, is known as a parabola. It is a quadratic curve. It is called a parabola. Fine. Parabola is what it is. So this is actually a parabolic curve. Fine. Well, Swecha, it's always true that if we have a quadratic curve, implies one of the variable is linear, y, and the other part is quadratic, ax square plus bx plus c. If that is so, in that case, the graph is going to be a parabolic one. Okay. That actually we shall later on learn it in the conic sections. Actually, in the coordinate geometry, we are going to look at the parabolic thing. The first one, this one. Why? Because both are negative. What happens if multiply minus 2 into minus 3, by the way? Minus 2 into minus 3 becomes what? It becomes plus 6, isn't it? In this case, we have therefore minus x into minus of x minus 2, and then I get simply the plus thing. Okay. The shape I'll draw, by the way, but the point is that this is actually a quadratic. At least, well, one thing is very sure: it's nothing but a polynomial. Okay, it's a polynomial. Well, exact shape, Tyasa, we'll have to learn it later when we consider the coordinate geometry. But for the moment, I'll show you what the shape is. In general, if you want to draw the shape, the basic idea is to just take up points, calculate dot of points, and join them smoothly. That's what it is to be done. But Once I'm telling you that the shape in this case is going to be a parabola. Okay. Well, how it looks like, let us see. The fact is, first of all, you notice that this is in fact a quadratic polynomial. Now it's already in factorized form, by the way. It's a factorized form. We have x and x minus 2. It's already factorized. You know the roots. The roots are 0 and 2. So I know that this polynomial, whatever it is going to intersect the axis at these 2 points. Because whenever we have a root for a polynomial, then we know that it's going to have a y coordinate of 0, which implies it's going to intersect the x-axis actually. Whenever we have roots, at whatever point the roots are present, those are the points where the graph is going to intersect the x-axis. Okay, so in this case, it's going to intersect the x-axis at 0 and at x equal to 2. These are the points where we have the intersection 0 and 2. These are the points. Now the shape over this shape turns out to be in this case a shape which looks like I was saying already, if you take up a rope and suspend it from 2 points, let me show you by this is actually not exactly a parabola, but it's a paraboloid. You see, look at this particular. Is it visible? The shape. It's almost like a bowl. But technically, I have actually 3D printed in this case. This is. Let us look at like this one over there. The shape that cross section look like the cross section that you're looking at this way. There is in fact a parabola. Okay. What actually I've done in this case is I have 3D printed a paraboloid. A paraboloid is nothing but a rotation or revolution of a parabola. Okay. It's like this, for example, for an upward opening parabola, and like this for a downward opening parabola. It's quite obvious why we call this as downward opening and why this is the upward opening. Okay, but the point is, in this case, the shape looks, as far as the cross section is concerned, almost like a rope which I'm just holding from 2 ends. If I just take up a rope and I just hold it at the 2 ends, for example, if we attain a shape which is like this, strictly speaking, it is not a parabola. Strictly speaking, that particular shape is actually known as a what do you call it as, by the way? Catenary. Okay, let's call it catenary. I didn't pause myself, by the way. Refresh. Okay, just see. I've not paused anything actually. In this case, for example, the shape is going to look like this. I just draw the graph for the moment. Um, That is how the shape looks like in this case. It is, as I was saying, if you just take up a rope and just suspend it like this, is okay. This becomes a parabola. This is a parabola. It's a quadratic curve. Whenever you have a second degree curve, y equal to a second degree polynomial, the graph is always going to be parabola. If the coefficient of x square is positive, the parabola opens up. But if the coefficient is negative, it opens down. Okay. In this case, the coefficient is actually 1. X square minus 2x. That's what it is. This is nothing but x square minus 2x. That's what it is. Fine. So it is therefore going to be having coefficient of 1 and upward opening parabola, so it's opening up. Okay. This will be the same graph for the 2 regions, x less than 0 and x more than 2. But if I consider the part which is in between 0 and 2, in between 0 and 2, if you remember, we had a minus sign in front over there, which implies I have to just simply flip the y coordinates, which implies that, talk about that later in Nilavrata. If I just look at the portion in between, this I said this part is only there if and only if x is going to be more than 0 or 2 and less than 0. That is only for this part. For this part over here is not required. I don't require the middle portion. Why? Because this is definition not valid. This is valid for 0 or more than 2. For the middle one, we saw that going back to the definition, I wrote down those 3 equations. The middle part is actually going to be simply negative of the, it was minus of x into x minus. It's simply negative of this part, which implies I have to simply flip the y coordinates. If I have earlier coordinate of, for example, 1 without the minus sign, like over here, then I put a minus sign, it becomes plus 1. Okay. So in that case, this part is going to be simply going to be flipped. That's what we're going to have. It just becomes flip over like this. This is going to flip like this. And so the entire graph is in fact the combination of these two. I have this portion in this part and then this part. That becomes a full graph of y equal to mod of x into x minus 2. Okay. Okay, fine. This becomes a required graph. Okay. I hope that is okay for everyone. Once again, well, why not? I said, first of all, I consider, you see, right now there is less to be explained, more to be, there is no special name for this kind of graph, Shivankar. It is just a piecewise curve, that's all. I was saying that we get, first of all, Moinak, we must remember that for a quadratic curve, it is always a parabola. Okay, if I have y equal to a into x square, I will send you a link. By the way, I written down an article on this particular thing. I'll just send you a link over there. Read it out. Okay. Something like this. If you have y equal to an expression of this form, ax square plus bx plus c. Okay, that is an expression. If I equate this to 0, I get a equation. But this is not an equation. This is an expression. So y equal to x square plus bx plus c. This is a quadratic expression. Always remember that this particular shape is always a parabola. Exactly whether this parabola opens up or down is determined by this particular factor a. If a is positive, in that case the parabola opens up. Now up can be anywhere, by the way. It can be something like the graph that we have drawn. It can also be above the entire x-axis. I mean, say for example, if a positive will give us a graph either like this, for example, upward opening, or like this, for example, or like this. They are all upward opening curve. Okay, exactly where they are or where the vertex located will be determined by the other numbers over there. Fine. However, if I consider a to be negative, it is nothing but downward opening parabola. Downward opening, so it will be like this or this or the general shape is going to be like that. Fine. In this case, I have just taken that part. I just drawn the first and third part. They were the same parabola, same curve. So it becomes this full thing, but only valid for x less than 0 or more than 2. So I just remove the middle part. But for middle part, it was simply a negative of that. So it was just opening downwards. So I just same parabola I've drawn the downward opening curve. I just reflected the same part above because I just put a minus sign. So where the initially the ordinate was -1, now it becomes +1, and therefore that's happening with everyone. Earlier it was like this negative thing, it becomes above, negative above. So each part is just going to flip up. That's it. Okay, that's how the graph is obtained. Fine. Okay, that's all for today. By the way, I've just tried to send you some questions regarding these inequalities, both linear kind and involving mod as well. And as I said, a bit of theory as well. And also, I just send you a link where you can read something regarding this quadratic expression. I wrote down any specific formula to plot it. Well, the formula is we had the formula y equal to x square minus 2x. That's what the formula is. Okay. If you have a plotting software, you can, for example, let me just show you. If I just have a, okay, I'll just show it later. By the way, today is too much time. Already it's going to be 10. You can leave today. Next time I'll just show it. Okay. But you can just do it if you have any plotting software, or you can do it manually as well. You have to just plot a lot of points over there. Fine. Yes, Subeksha, what have you? What question? So anyone, people who are trying want to leave, they can leave. Okay, that will be all for today. We shall just discuss from here the next time. No problem, Subeksha. You can ask whatever it is. I'm going to stop the recording. Well, Desmos I do not use.